Hey guys, let's take a look at some old stuff. Today it's solving equations in 2 steps. But again, like Saxon, the genius of this is let's go back and do something we already know how to do, and then we'll add a little bit to it and it'll be a piece of cake. So let's look at an oldie here. How do you solve something like this? You have x over 3 is equal to 2. Well, again, don't forget you can rewrite this thing like there's a 1 there. And if you write it like this, you go 1x over 3 is equal to 2. Well, if you want to look at it this way and go, oh, that's a third of an x, you can do that. So let's just write it that way if you like to look at it that way a little better. And we know to solve this, anytime we see a fraction in front of a variable, we just multiply it by the reciprocal, right? So the reciprocal is 3 over 1. We can do that in our heads, right? 2 times 3 is 6. There you go. We can check it if we want to. Does 6 divided by 3 equal 2? Yes, there's the answer. Okay, so let's look at this one. Same thing. If we don't have a fraction, but if we just have an integer in front of the variable, like 3x equals 18, we just divide both sides by the integer. Which is, again, if you were thinking of it this way, in case, if you oh, that's 3 over 1, x equals 18, you go, oh, wait, that's going to be 1/3, blah, 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 and so on. So, anyway, you'd multiply by 1/3, multiply by 1/3. But the same thing is divided by 3. We all know 18 divided by 3 is 6, and there's your answer. Okay, let's look at another one. How do you do this one? There's only one thing to do, right? Okay, you have a 2 sitting there you want to get rid of. To get rid of it, you subtract 2 here. It's an equation, equals, means this is equal to that, like it's a big seesaw, and you have to have exactly the same on both sides here and that side there, okay? All right, so you subtract 2, and then x is equal to 6. You can check your answer if you want to. All right, one more. How do you do this one? You want to get that -3 out of there, so you add 3. So you add 3 to there, and then x is equal to 6 again. You can check it. 6 minus 3 is 3. Yep, that works. There we go. Okay, now what we're going to do is combine both those things we just did in the last couple of slides. And here's the deal. You know the order of operations, right? Where you do parentheses first, or the other symbols of inclusion, like brackets or whatever. Exponents or, radicals. Then multiply and divide left to right, and then I think I just pointed the wrong way, maybe with this mirror thing or whatever. Anyway, multiply and divide left to right, and then add and subtract left to right. Okay, so when you see something like this that has not only we're going to have to do this, we're also going to have to do this as well. What you're going to do is backwards. So instead of doing multiplication and division first, we're going to add and subtract first to solve an equation. All right? So the first thing we need to do is get rid of this -2. Well, we'll add 2 to both sides, right? So plus 2, new equation, 3x is equal to 9, all right? Well, we all know how to solve this now, right? Anytime there's an integer in front of a variable, we just divide by the integer. It always, by itself. And then 9 divided by 3, which is, of course, 3. Now, you can look at this and go back and very mentally check this if you want to. If x is 3, that means 3 times 3, 9, minus 2 equals 7. Is that correct? Yep, that just proves we're right. Okay, let's try another one. 3x plus 2 equals 19. Go ahead and, copy that down, pause if you need to. Okay, well, to solve this, we're going to have to first get rid of the +2. And we do that by subtracting on both sides. So here's our new equation now. 3x on the left, 19 minus 2, 17 on the right. And then the last step, you can get to a point where you don't need to actually go through all these motions of doing that. You can just go, and that goes away. I'm dividing by 3. X is equal to 17 divided by 3. There I go. And that's it. There you go. That's all there is to it. You can actually check this again if you want to and make sure it works, and it will if you multiply the fractions correctly. Okay. Well, look at this. Pause and copy there too. Okay. Don't get intimidated by this. We already know the method, right? When you know a method in algebra, use the method. It will work, okay? I don't care if you're in calculus several years from now, you're going, oh, no, what do I do? Oh, no, the method is that you do the same thing you did back in whatever year you looked at this video, okay? So the method is we get rid of the stuff, by the coefficient and the variable, then we divide, and then we got it, or multiply by a fraction or whatever, okay? So again, what are we doing first on this one? We are looking at this part right here. We don't care if it's fractions, we do the same thing, okay? So we're just gonna go, okay, 2/3 x, and if you want to think, okay, it's plus a half over here, and then plus a half over here, same thing, right? So let's go over here kind of to the side, and let's add these two things together. Of course, we can tell that the common denominator is going to be 6, right? So 6 here and then 6 there. 3 times 2 is 6, 10 times 2 is 20, 2 times 3 is 6, so it'll be 3 there. This will turn into 23/6. So this 2/3 is equal to 23/6. There we go. Okay, what's the next step? We need to clear out the 2/3 by multiplying it by 11/8. That's right. No, I'm just kidding. Okay, it's 3/2. All right, so multiply by 3/2. You don't have to actually write that out every time and go, okay, that will, you can just go ahead over here and go, okay, well, I'm going to multiply by 3/2. I know the answer is going to be x over here. All right, let's get a little reducing here. That's gone, and this is gone. That'll be a 2. So 23 times 1 is 23. 2 times 2 is 4. Okay, so x is 23 divided by 4. That's all there is to it. Now, if you wanted to go back, let's say you had plenty of time, and you wanted to go, oh, gee, I wonder if I'm right or not. Well, go back and plug the thing back in there. Let's try it. We say that x is 23 over 4. Okay, so I can just plug in, instead of writing an x here, I can just write 23 over 4. Okay, then I'm claiming that if I subtract a half, then that will equal 10/3, right? So this is what we're messing with right now to check and see if it's right. Well, let's do it. 2/3 times 23/4. Let's see, that goes away, and that's going to be a 2, right? So that's 1 times 23. 3 times 2 is 6. So 23/6 minus a half. Let's just make this into a common denominator. A half will be 3/6. Okay. So 23/6 minus 3/6 is 20/6, right? Well, is 20/6 the same thing as 10/3? Look at it. It's the same thing, right? 3 times 2 is 6. 10 times 2 is 20. We just proved it works. You don't have to do that every time. Just, if you're ever not sure if it's a test or something like that, or some kind of a, I don't know, if mom's holding you hostage and won't let you have any food until you check and see your answers right, then yeah, I would go ahead and do that. Okay. All right. Let's try another one. Pause it and copy. All right. Back. Same exact thing except for one difference. What is it? It's a mixed numbers, right? Who cares? Just turn them into these kind of numbers. Same thing. Make the new look like the old look, and then you can do it. In fact, you're going to see a lot of stuff we do from now on is going to be, oh wait, I don't know how to do this. I'm going to make it look like something I've already done before, and then, oh yeah, I know how to do that. Okay, another brilliant thing about Saxon. All right, 2 1/3 x is 7/3 x. Minus 1 1/5, that's 6/5. Equals 23/10, just leave it. All right, we need to get rid of this part right there, which means we're going to add 6/5 to both sides. And then we'll add 6/5 to both sides. And you know what? I'm just going to go ahead and do this in one step here. 6/5, that's the 10 there. That's the same thing as 12/10, right? So 23/10 plus 12/10 is 35/10. And we can reduce that, right? That to a new, a reduced fraction. Well, 5 goes into both of those. That's going to be 7, and that'll be 2, okay? So our new equation is this. 7/3 x equals 7/2. That makes sense? Now, if you saw this, we've got to this point right now. If you saw this yesterday or last week or whatever in your problem set, you would go, oh, yeah, it's a piece of cake. I just multiplied by 3/7, right? The reciprocal. And you got it. So let's just do that. Multiply by 3/7. Look at there. That's handy. X is equal to 3 on top and 2 on the bottom. There you go. And you could go back and check this if you want to. And I know you want to. Okay. Again, if mom withhold. Yeah, okay. Yeah. All right. All right. Let's try the practice problems. There are 4 of them on page 196. So go ahead and pause it and try number A. All right. Piece of cake here. I'm just going to move this 1/6 over. Again, just as a reminder, if you move, you can move things in algebra over here on the other side. The idea is if you move something from one side to the other side of an algebraic equation, then you just change the sign of this. So this won't be negative 1/6, it'll be positive 1/6. Again, that's the same thing as going, oh, I'm going to add 1/6 here and add 1/6 there. It's the same thing. So plus 1/6, there you go. So that's gone. We just have 2/3 x on the left. And let's just mentally do this. Okay, 1/2 with a 6 as a denominator will be 3/6, right? So 3/6 plus 1/6 is 4/6. Reduced will be 2/3, right? Well, let me ask you something. 2/3 times what number gives you 2/3? 1, right? But let's just go through the motions, okay? So we multiply both sides by 3/2, right? So multiply by 3/2. There you go. That's gone. Hey, look, the 2's cancel, and the oh, it's just 1 divided by 1 or 1. There we go. That's all there is to it. Okay. All right, pause it and try B. All right, piece of cake here. Let's go ahead and change this into a mixed or an improper fraction. 5/2 x. You know what? Let's go ahead and move this over in one step, right? Let's go. To get rid of this, you subtract 1/8. And we can look at this as not 1/4, but 2/8. So what is 2/8 minus 1/8? Well, the answer is 1/8, right? And what do we multiply both sides by to clean up? 2/5, right? So let's just do it. Multiply by 2/5. That's gone. And look, it cancels. There's a 1 there, and there's a 4 there. And let's see here. 1 no times 1, and then 1. Nope, there we go. 1/20. That's all there is to it. Okay. All right, let's try C. Pause it. Okay, well, this is going to be 5/4 x minus 1/3 equals 3/5. You move this over. In other words, you add 1/3 to both sides. And 5/4 x. And we'll go ahead and just go 3/5 plus 1/3. All right, unless that's gone. And let's just do the common denominator, which is 15, right? So 3 out of 5 multiplied by 5 there, it'll be 15. That'll be a 9, so 9/15. 1/3, that'll be 15 there, and then 5 there, so 5/15. 9/15 plus 5/15 is 14/15. And the last thing we do is multiply by 4/5, right? All right, so here we go, 4, and then 5, and then there we go. So I don't see any canceling we can do here, so x is going to be 14 times 4 is 56, 15 times 5 is 75, and I believe that should do it. Okay. Do we do that right? Does that look right to you? 1/3 plus 3/5? Okay, I think that's pretty good. All right. Okay. All right, that should do it. All right, pause it and try D. See what you get. Okay, well, same old thing here, right? 2/7x plus 1/5. Let's change this to 21/10. And let's get this over on that side. So we will subtract 1/5. You know what? Let's just do the 10th part. 1/5 is the same thing as 2/10, right? So gone. So now we have a new equation. 2/7x equals 21 minus 2, 19/10. And to clean this up, you multiply by 7/2. What kind of a rotten fraction is this? What in the world? 19 times 7? I guess we all remember our 19's tables, right? 19 times 1 is 19. 19 times 2 is 38. No? Okay. 19 times 7 is 133. 10 times 2 is 10d2. No, okay, no, it's 20. Okay, there you go. All right, and there we go. Okay. All right, you guys have fun at that today. Just make sure you get the method down, and good luck. We'll see a lot of those in the next several weeks. So see y'all next time. Do your best.